In this example, we'll use a method where sometimes if you have a fraction and there's more than one term in the numerator, we split the fraction into multiple parts, one for each term. So the reason that we're going to try this approach in this problem is because typically when there's a square root of something x squared in the denominator, you have to find the antiderivative in a different way when there's an x in the numerator, when there's no x in the numerator. So we'll see the difference when we split this fraction apart. Okay, so I rewrite it as two integrals. So this is the integral of 3x over the square root of 4 minus x squared dx. So that's the first integral, plus, then the second integral is 1 over square 4 minus x squared dx. Okay, right, so again we split the fraction apart by each of the terms and by distributing the denominator. Okay, so we see here the second integral has a simple antiderivative. So when you have an integral of the form 1 over the square root of some constant minus x squared, then the antiderivative is the inverse sign. So the antiderivative of this is just the inverse sign of x over a, where the a is the square root of this number here. Square root of 4 is 2. Okay, so now we go back to the first integral. So the approach to this integral is different. So here we have to use a substitution. So we let the thing inside the square root be the substitution, and we'll see how to integrate this. So for this, we let u equals 4 minus x squared, then du equals minus 2x dx. So that means that dx is equal to du over minus 2x. Now doing the substitution, so this goes inside the square root. So we'll leave the 3x alone for now. So the u goes inside the square root, and then the dx becomes this thing here. So now you see that this x cancels with this x. I'm going to pull the constants out, so minus 3/2 the integral. So I can rewrite this as a fractional exponent, to u to the minus 1/2 du. Now we just apply the power rule. This minus 3/2, add 1 to the exponent, so the minus 1/2 becomes plus 1/2. Divide by the exponent. And then we simplify this expression. So this 2 goes on top, and it cancels out with this 2. So we're left with minus 3. And then u to the 1/2, I change it back to a square root, and I substitute u back in. So 4 minus x squared. So that was this first integral here, and then I have to combine it back with the second part. So plus inverse sine x over 2 plus c. So this is the antiderivative. So we see again that for this particular integral, we first split up the integral, and we do each part separately, requiring different methods for each part.